Okay, so synthetic division is basically this. It's a shortcut. Now, the other option that we're not going to look at is long division, and it's like it sounds like. It's a long division process. So what synthetic division is just a little spin-off of that. The big two things, it's really, I've got repeated twice here. We've got at the top that the terms have to be in standard form or they're in descending order based on the powers of x, or whatever the variable may be. Most times it's going to be x. And the other thing, too, is that the second thing is if any of the variable powers are not present, if they skip over a power of x, you've got to include those powers, but they have to have a 0 coefficient. Okay, now we've got all these steps through here, but again, when you actually start working this part out, they're not near as long as it seems like. So what we'll do is we'll kind of just go ahead and set up the problem and see what we've got here. Okay, so underneath the steps we've got. Step 1 is just a repeat of the two things we had up here for the first part, so we've got to make sure the terms are in descending order and all the powers of x are present. So that's just a repeat of the first two steps. So here's the problem we're going to do. We're going to do x plus 5, and we're going to divide that into, for the first one we'll start short. We'll start with 4x squared plus 23x minus 16. Okay, so the very first step, if that's our problem we have. So with our division problem, the very first thing we're going to do is we're going to draw the division bar we have here upside down. And again, we're going to leave a little bit of room in there, so we're going to put some more numbers in there. So the very first thing we're going to do is draw this upside down. And the online homework shows it a little bit different, but it's still the same basic process here. And we're going to bring down just the coefficients that's on the inside. And again, coefficient is the number that's in front of x. And we are going to include the signs. So we're going to have a positive 4. We're going to have a positive 23. And we're going to have a negative 16. Okay, on the outside, we're going to bring not the number in front of x, but we're going to bring this number that we have here, this plus 5, we're going to bring it down, but we're going to change it from a positive 5 to a negative 5. And the only reason we don't do anything with this 1 is that with synthetic division, we're always going to know that this first number is going to be x plus or minus something. So that part's going to be given. Okay. Next step is, now we're going to take the inside number, we've got here this first number, and we're going to put it below the division bar. So now we're going to do this. We're going to take the outside number here that's negative 5 and multiply it times 4. So negative 5 times 4, and we'll kind of go dashed it in here. Do negative 5 times 4, that's going to be negative 20. Taking that negative 20, put it in the next column on the inside, so it's here. And now whatever these two numbers are, you add them or subtract them. If it says addition, you add them. If there's subtraction, you subtract. So it's 23 minus 20. And again, put the sign, that's a positive 3. Good. And then the next thing is, now we're going to go back and repeat. Now we're going to do negative 5 times positive 3, and we're going to put that number in the next column. So negative 5 times positive 3, that's a negative 15. If you've got negative 16 and negative 15, that's going to make that a negative 31. Okay, so we've done all the adding, subtracting, and the multiplying we can do, so basically we were all the way down to the last part of it. And then number 9 says, the answers you have here are the answers to the question. Now, it's just numbers, so we've got to go back and put the variables in. So what we're going to do is, because we're taking, here's kind of the basic sense of it, because we're taking 4x squared and dividing it by x, every time we do that, we're going to basically just bring everything down a power. We can cancel this one out and cancel the power out here. So whatever the first highest power is that you have, you're going to start with one less power than that. So it's going to be 4x. If you take the next term and divide it by x, we're going to take this x off, so it's going to be just the number, so plus 3. And the last number that's here, that's going to be your remainder. And there's either going to be one of two things. They're either going to give you a box where you just put the remainder in the box to get the answer, or you're going to do the 4x plus 3, and whatever the remainder is, it's minus 31. That's going to be over whatever we divided by, so x plus 5. So that's one of those you just have to kind of watch and see how the problem is and how they set it up. I know on the test it's kind of both. Sometimes I'll ask you just for the remainder. Sometimes I'll ask you to write it like this, where you put that remainder over whatever it was we were dividing by. Okay, so that's the basic setup when we're going through synthetic division. That you're going to, and again, it's a lot of steps, but when you do the problems, you realize it's not as long as it looks. It's just there's a lot of steps to it. But the steps themselves are all really short because sometimes you're just changing one sign, you're flipping a division symbol upside down. You're adding and subtracting and multiplying when you're going through these. Okay, so let's give you a couple more. And then we'll throw a couple of little, still doing synthetic division, but just changing up a few things that they're going to give to you when you go through some of these. All right, example 2. We're going to take it up, instead of starting off with x squared, we're going to take it up to x to the third, which I think is where most of the homework is going to be. Okay, for example 2, we've got x minus 2. We're going to divide that into x to the third plus 2x squared minus 5x plus 3. Alright, step 1, you're doing two things. You're checking to see if these terms are in descending order, and they are, because we've got x to the third, x to the second. Basically, you've got x to the first here. And then we've got a constant, which means that's x to the 0. So the powers are good there. And all the powers are here. We start off with x to the third, we've got x to the second, x to the first, and then just the constant term. So we didn't skip any powers of x, so all that's good. So now we're going to flip this thing upside down and bring down just the numbers. So we've got 1x to the third plus 2x squared minus 5, and then the plus 3. And then the one thing, and again, by having your notes for this for the test that's coming up, change that sign of the outside number. It's a minus 2, change it to a plus 2. And then bring down the 1. So that first number is always just there to kind of get you started. You don't do anything with it. You just bring it down below there. This helps you set up everything so you can go from there. Now we're doing 2 times 1. Which would be 2. 2 plus 2 is 4. Now we're going to do 2 times 4 to make that 8. And we've got negative 5 plus 8, so that's a positive 3. And then we're going to do positive 2 times positive 3 to make that a positive 6. And then 9 plus 3. 6 plus 3 is 9. Alright, and again, if you look at the basic sense of everything, we're taking x to the third and dividing it by x, so what that's going to do is it's going to knock this first term down by 1 power. So that's going to be, and again, you don't have to have the 1 because it's just understood that's there. It's going to be 1x squared plus 4x plus 3, and that last number is going to be your remainder, so your remainder would be 9. So that's one option you may have. Again, the other option is they may do the same thing, but instead of your remainder being just the 9 by itself, you may do plus 9 and put that 9 over x minus 2. But the biggest thing is that the front part's the same. The remainder is just, it's more of just how they want it. Sometimes you can just put a box and they'll have you put the remainder in. Sometimes they'll have you write it in fraction form. So it's just kind of a 50-50. You know, you can go either way here. Okay, now everybody kind of watch this one, because this is the one that sometimes people get a little bit lost on. Because so far, the first two examples, all the terms were there, everything was in descending order, we were good to go. Let's give you one now where it's not that way, where you actually have to kind of work and adjust a little bit. And this is one where sometimes they'll word it a little bit different, but it still means the same thing. Let's divide 4x squared plus 6 plus x to the third by x plus 3. Okay. Now, first thing is, if we rearrange it, we've got the x plus 3 that would be here. And let's get these in descending order. So we've got x to the third. Highest power's got to go first. That's your degree. So that part's still tying in with everything we did back in section 1. They're going to ask for standard form. When you divide it, it needs to be in standard form. So we've got our highest power of x first. We've got x squared next. And we've got the 6. Okay, so now it's in descending order. But we've got x to the third and x to the second. There is no x to the first. So since x to the first is missing, that's where we're going to have to go back and put a 0x in there for a placeholder. So every time they leave off a power, you've got to go back and put a 0 in there for a placeholder. If not, your division gets off. So we've got 1x to the third plus 4x squared. In the 0, you can put a plus in front of that, even though it doesn't really matter because it's 0. But we'll put a plus 0 and then plus 6. And on the outside, we're going to change it from a positive 3 to a negative 3. Okay, so terms are in descending order, and again, we had to put the 0 in there for the x because we skipped the x term, so we've got to put a 0 in there as a placeholder. Okay, bring down the 1. And now we start to multiply. Negative 3 times 1 is a negative 3. 4 minus 3 is positive 1. Negative 3 times 1 is a negative 3. And with the 0, 0 doesn't do anything when you add or subtract it, so it's just going to leave it as a negative 3. And then negative 3 times negative 3 is going to be a positive 9. Add those two together to get 15. Okay, and again, you've got to, once you've got them rearranged, you're actually not looking at this problem anymore. We're almost here. So when we start writing out the terms, our highest power is x to the third, so we have to start with x squared. So we've got 1, or just x squared, plus, and you can do the same thing here, it's plus 1x, but again, you don't have to have the 1x there. Minus 3, and your remainder would be 15. Or again, you may have to write it in fraction form at the end, so put that 15 over x plus 3. Alright, for the next problem, what we're going to do. Let me just give you one, let y'all practice, see what you can do with it, and then we'll come back and check it. So if you're watching this one online after we set up the example, just pause it, work it out, and then we'll let you see if you get the same thing. It is. Okay, so for example 4, let's divide x plus 2, and let's divide it into x to the third plus 4x squared plus x minus 6. Okay, first thing we've got is we're going to change that from a positive 2 to a negative 2. Flipping this upside down, we've got positive 1, positive 4, positive 1, and negative 6. Okay, first term again, just kind of holds it in place. It's negative 1, or sorry, we've got the 1 here. It's negative 2 times 1 for a negative 2. 4 minus 2 is just 2. Negative 2 times 2 is a negative 4. 1 minus 4 is a negative 3. And then negative 2 times negative 3 is a positive 6. We've got a 0. Okay, two things on this one. What did you see? If you get a remainder of 0, when you ask you to write this in, we're going to have x squared plus 2x minus 3. If the remainder is 0, and if they don't ask you anything about the remainder, just writing it out, then that would be your answer, just doing x squared plus 2x minus 3. Now, here's where, in some of the, I think there's one problem in there where in the homework, when you're going through this one, they're going to ask you to do synthetic division, but after you do synthetic division, they're going to ask you to factor completely. So here's where they're making you go back to sections 2 and 3 when we're factoring. It basically is this. They're telling you, all right, after you've done synthetic division and you got to here, this part that you have left over that's in your answer, they want you to take this answer that you have and go ahead and factor this thing. Now, it should be simple, easy factoring for these. So what are the factors of 3? What's the only factors of 3? It's got to be 1 and 3, right? It's the only way you can get 3. So for this one, it's all about the signs. Since the b term, since we're looking for something that's going to be positive 2, 3 is going to have to be positive, which means then that for this to be a negative 3, negative divided by positive means this is going to have to be a negative. So now the final answer is that because way back in the beginning back here, we did have this x plus 2 that made this remainder be 0. So the final answer then, if they ask you to factor completely, is you're going to use this answer we divided by up here, this x plus 2. And we're going to put that with the rest of what's factored out down here. So if they ask you to do synthetic division, you would stop here. If they tell you in the problem to factor completely, is they're telling you, all right, this remainder should be 0, and you've got to take the answer you have and factor it and go from there. Now the good news is, if they do give you a problem like this, the factoring should be easy. You're not going to have to do bottoms up or any kind of factor by grouping or anything like that. It should be just a pretty simple, straightforward part of that one. And on the very last thing on that handout we had about the extra notes, it said if your remainder is 0, then what you divide by is a factor of the expression. That was kind of where that part comes in for this one. And what we're going to do in the next sections, when we get to sections 5 and 6, is that now we're going to take each one of these things we've got here, set them equal to 0, so then we can find these that are going to now be solutions. So that's where it's kind of spinning off what we did on the last test, to kind of bring back in with this test. Okay, and then the one last thing that they're going to have you do is the remainder theorem. It basically is this. The remainder theorem, sometimes they call it the factor theorem. The only difference between the remainder theorem and the factor theorem is the factor theorem wants the remainder equal to 0. Remainder theorem, it just says plug this in and you'll get the remainder every time. So there's really not a big difference on the two. But basically is this remainder theorem. It is a check. Or you could almost look at it this way. It's another option. So really it's a check, if you want to look at it that way. It's a check to synthetic division. Because some problems they'll tell you can use the remainder theorem or synthetic division to find the remainder. If you're just finding the remainder, you can do either one. If they actually want you to do synthetic division, then they're probably going to tell you to do synthetic division on these. And basically it's this. Here's what you're going to do. You're going to use the number. Actually, it's the outside number. Use your outside number from synthetic division. So use the outside number from synthetic division to evaluate the expression. And basically is this. The answer you get from that evaluation should be the remainder you would get if you did synthetic division. Now, the biggest thing I've noticed in the homework is sometimes they tell you to do both. You don't have to do both. Now, they kind of do that to tell you to check your answer. But if you're just getting a number, you can put it in. And the check for the online homework is if you put it in and the answer is correct, you've got the right answer. You know, if you miss it, then that lets you know, okay, I did something wrong. I need to go back and check it for that part of it. So they tell you to do both. You really don't have to do both. It's one or the other when you're going through this. All right, so let's do this. So they may do something like this for the problem. They may tell you to find the remainder when you divide, and then they'll give you the expression. Let's go with x to the third plus 8x squared plus 10x minus 2 when you divide it by x plus 2. Again, you can do synthetic division, but in this case they're telling you, all right, actually go ahead and just find it. You don't have to worry about everything else. We want just the remainder when you get off this part. And honestly, this is one of those things where it comes down to, would you rather use the calculator or would you rather do the work by hand? Because here's where it kind of comes into the calculator part of it. Since we're dividing it by x plus 2, the one thing you have to realize is that we're going to plug in. You still have to change the sign if they give it to you like this. So we're going to use, or we're going to evaluate, x equals negative 2. Because we're dividing by x plus 2, which means we've got to evaluate x equals negative 2. So everywhere we've got x in this expression, we're going to take the negative 2 and plug it back in. So that's negative 2 to the third power plus 8 times negative 2 squared plus 10 times negative 2 minus 2. Now, we can work all that out, but since we've got the calculators here, just use your calculators. Now, one small thing I need to show you, if we're going to evaluate that one, we've got negative 2 to the third power. On here, we don't have a third power button because you've got your squared button that's here. If you need to do the third power, so we've got negative 2. Right above the x squared button, The next button up, you've got this what looks like a rooftop or an arrow. If you hit that one, that's your power button. So that's -2, and then you put 3. So now you got -2 to the third power. Then we had +8, parentheses, -2 squared, plus 10 times -2 minus 2. Alright, plug that in and we get answers 2. Okay, so if they ask you to find the remainder, now you could go back and do syntactic division and look for that last number. But at the same time, if they tell you just use remainder theorem, all you're worried about is that number. That's one where you can basically just use your calculator to punch it in and then get the answer that you're looking for. The only other question they can do that kind of spin off this one is they may ask you, is x plus 2 a factor? And basically the answer is this. If this equals 0, if your remainder equals 0, that's a yes. If your remainder does not equal 0, that's a no. So for this one, since the remainder equals 2, if they ask you, is x plus 2 a factor of that expression, well, then that part would be no. Okay, so everything else that's in the section, it's going to be doing either one of two things. You're either doing synthetic division, or if they talk about finding the factor theorem or the remainder theorem, that's where you're going to take whatever value they give to you, whether it's like this, or sometimes they actually just give you the number. They say, all right, here's a value, plug this in and see what you get. So that's where you're just going to plug the numbers in, work it out, and if it's a remainder equals 0, it is a factor. If the remainder is not 0, if it's something other than 0, then it's not a factor.